All right, hello everyone. This is Chapter 2, Section 1. Um, the beginning of Chapter 2 is just some ways to organize data. So, uh, besides doing some analysis with, computing an average, or as we'll see, some other measures of data, data visualization is an important tool to help you see patterns, right? So, um, here's what I mean. Look at this list of scores. We have these pre-calculus class scores for the first exam, and like there's just a list of numbers, right? And when I look at these, I just like I can't see any patterns. I don't see any information. Like, we're not really built to look at a big long list of numbers and just immediately see what's going on. Maybe there's people out there built like that, but I'm not. I am not built different. I cannot see something special there, and most people aren't. And so that's why we've come up with data visualization. Oop, fell out again. Sorry. That's why we came up with different ways to visualize data to help us see patterns, because the patterns are going to help us interpret, make predictions, and so on. Right. So one of those is called a stem and leaf plot. So I'm going to pull the stem and leaf plot. This is from your textbook, of course, like all the examples. And here's the stem and leaf plot that they made. So look at it. Now you might be looking at that and going, Taylor, that doesn't look any better to me. Like, what's the difference between that list of numbers and this? But look at it. Look, so the stem, if we look at these numbers here, these were scores. So they're all going to be up to 100, right? Most of these are double digit scores. So the stem is the tens place and the leaf is the ones place. Just by organizing it this way, what we've done is given us a way to visualize the most common score. Look, looking at this data now, looking at the stem and leaf, I can tell you most of the scores were in the 60s and the 90s. Can you see that from the stem and leaf plot? How do I know that? Well, I mean, look, I got this chunk is longer than the rest of it, right? This chunk is longer than the rest of it. There's more scores that were in the 60s. I had a 61, a 63, a 67, a 68, a 68, a 69, and a 69. And then I had a 90, a 92, a 94, 94, 94, 94, 96, right? I can see now that there's more scores there. So it's useful, right? Now, how you end up defining the stem and leaf depends on the data. So, maybe you have stuff that's got 3 digits, so you want to use the 100s place as the stem and the tens and ones as the leaf. Or maybe you got decimal spots, so you have the ones place as the stem and then the decimals as the leaf. It depends on the data. You have to figure out what's most appropriate, but it does let you visualize, right? And we can also see, like, look, I see that there's exactly 1/100, right? And it also, now notice this data was already put in order for us, so that makes it a little bit easier. If you're making a stem and leaf plot, you're probably going to have to sort the raw data. Now, I do not recommend sorting the raw data by hand. Put the data in a spreadsheet and then use a sort option. It's well, heck, let me show you how this is already sorted, but I'll show it to you anyway. Actually, I don't know if I can. Maybe we won't use that data, but just as a side note here, uh, let me get a spreadsheet open. This is definitely an off the cuff idea, or else I'd have this ready for you. Sorry. MAT203, student resources. Let's make a new spreadsheet. Should like have this saved as like the lecture spreadsheet or something. Maybe I'll do that. The spreadsheet. I know you can't see it right now. I'm going to move it to the window you can see in just a second. Okay. Here's the lecture spreadsheet. Let me show you how to sort with this. I'm just going to make up some numbers. Oh no. Well, helps if you actually uh, type in the right spot. Okay, that's enough. Okay, here's some data. I'll highlight it. And let's see. Data. Sort. Aha. Smallest to largest. Let's do it again. Data. Sort Z to A. Now, It's numbers. It really should say largest to smallest or smallest to largest. And sometimes it does recognize that, but sometimes it leaves it on alphabetical. But, do it backwards. Bloop. Hey, there it is. Largest to smallest. Okay, so data, sort. You know what the secret to being good at Google Sheets is? I mean, it's Google, right? I don't know how to do this. Hey, Google, how do I sort? Telling you, 9 times out of 10, when I don't know how to do something on Google Sheets, it's like the first Google search result, right? You just look it up; it'll be good. Plus, of course, remember I gave you that big spreadsheet with lots of example functions, right? Okay, so back to it. Let us do this is 2.1 example from your textbook. The Park City basketball team scores for the last 30 games were as follows, and they've already been ordered for us. Oh, that's so nice. Construct a stem plot. Okay, I'm going to do the same thing as before, where my stem is going to be my tens place and my leaf is going to be my ones place. I want to emphasize it is not always tens place is the stem, ones place is the leaf, right? It just so happens that this data and the previous example were like that. It depends on the data that you're using. You got to think about what makes the most sense, what's going to organize the data. The whole point is to organize the data in a way that helps you understand it better, right? So, okay. I have my stem here. I have threes, fours, fives. Now that I've started at 3, notice I didn't do ones or twos because I didn't. The smallest number was a 30. But even if we happen to skip one, I'm not going to skip over that. I'm going to go ahead and write the numbers in between, although it looks like it's not a problem. And the largest number is a 6, so I'm not going to write 7 or above. And leaf. Okay, for the 30s, we've got a 2, 2, 3, 4, 8. 40, I got 40, 42, 42, 43, 44, 46, 47, 47, 48, 48, 48, 49, 50, 50, 51, 52, 52, 52, 53, 54, 56, 57, 57, 60, 61. Okay, so now we've organized the data. What can we see visually? Most of the time, the Park City basketball team had scores in the 40s and 50s. That's not immediately obvious from the original version of the data, but the stem and leaf plot helps us see it. Okay, in this section, there's a couple other ways you can organize data. One of them is, and by the way, there's lots and lots of examples. The book is actually really, really great at giving you an example, and then there's going to be it'll show you the solution, and then it'll give you one without the solution. Even if you don't do any of the the homework problems that are the exercises that are below in each section, I mean, you can, it's free extra practice, right? But even if you don't look at those, looking at the examples in the book and trying them is really going to help. I promise that's the best way to do it. I hope that these videos are helpful. I hope that the other videos that I have, the supplemental videos, are helpful. Dang it, the thing fell out again. You know what I just realized? Okay, I had, um, I had. Let's see. Look, I had intended to set a timer for 15 minutes to make sure my video doesn't go too long, and I forgot to start it. Oh well. I usually end on 15 minutes anyway, or around 15 minutes. That's fine, right? Anyway, um, I hope that the videos are helpful, but you have to do stuff, right? If you don't try the problems, it's not going to make any sense. It's always going to feel like nonsense. Okay, you have to try the examples. Okay, so the next type is called a line graph. So the idea is this: you on the x-axis you put the values, and on the y-axis you put the frequency. So I've got some data here. In a survey, 40 people were asked how many times per year they had their car in the shop for repairs. Results are shown in the table. Construct a line graph. Again, this is from the textbook. So number of times in the shop. So the value itself is the x-axis. So I've got 0, 1, 2, 3. Notice that's a little bit different from I've got 0, and I'm going to do my vertical axis here. I don't have 0 at the origin, right? Normally, you might be used to like when you've done in algebra, you drew a XY coordinate plane and you graph something. The 0, 0 point has to pass where the axes cross, right? That's not really true for this type of graph because 0 is not a coordinate as much as it's a value for your data. And you want to know the frequency for 0, right? So how many, for the 40 people who surveyed, how many of them said, "Oh, my car wasn't in the shop in the last year"? And according to the data, 7 people said that. And we got to come up with an appropriate scale for our y-axis here. I got 7 through 14. Let's go by twos if we can. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, that should be good enough. All right, so 7, 2, 4, 6. So we have 7 here. And then a 1, where there was 10. And 2, we're going to have 14. And then 3, we've got 9. And then we're just going to connect. So the reason that we're connecting, even though it doesn't your car can't be in the shop 2.5 times, really, right? Remember, this is an example of discrete data. It's either in the shop and that's a time, or it wasn't in the shop, right? There's no half of a time or a quarter of the time in the shop. But the reason that we add the lines is to help us visualize the trend, right? What's going on? This is like one of the few times where you do actually connect the dots. When you get to correlation, you do not connect the dots. Don't do that, right? But for this, we do, and because we're trying to say, like, okay, as we go through, what's kind of the pattern, right? And so you think about like a number of times in the shop. Well, as we go up to 2, it gets more and more frequent, and then there's kind of a drop off, right? Seems like the most, and you can see, hey, what's the most frequent amount? What's the highest part? Well, 2 times a year seems to be the most frequent part. Okay, and then a bar graph. You've seen a bar graph before. You've made bar graphs many times in your life. I'm not going to draw a bar graph for you. If you're like, oh man, I need a bar graph example, you let me know, but I'm betting that you've done a bar graph before. And I think I've drawn a bar graph before in a previous video. So we'll stop there for Chapter 2, Section 1, and I'll see you in the next one.